So let's jump straight into the reaction quotient. So to begin, the reaction quotient, the same formula as KEQ. So reaction quotient represented by QEQ, right? It's represented by QEQ. And it has the same formula. It has the same formula as KEQ, right? And it is calculated for a given system to determine if the system is in equilibrium. So this is calculated to check if is the system in equilibrium, right? That's what they want to know from KEQ. Right? Is the system in equilibrium. Now, the value of my QEQ can mean three different things. So we have three different cases. We have three different cases here. We have three different cases, right? So for my case number one, I'm gonna write this all in blue here. For my case number one, we can have if my QEQ is equal to my KEQ, then therefore my system is in equilibrium. Right? Now, for number two, my QEQ is greater. If it's greater than my KEQ, then my system must shift to the left. And the reason for this is because the product to reactant ratio would become too high. All right, so and for number three, my third case, which would be if my QEQ is less than my KEQ. And if that's the case, then it would be opposite of this, and my system would shift to the right. All right, so those are my three different cases. All right, so this is a sample problem we're working with first. The following reaction occurs in a closed container at 445 degrees Celsius. The equilibrium constant K is 0.020. Okay, this might be information needed for the future. Okay, so and this is our actual reaction here. So, and this is our given information. So let's look at our given information A, and this is our given information for B. Let's forget about that now, and let's look at some important things here. So firstly, the first important thing I want you guys to look at is that how QEQ has the same formula as KEQ, and basically the formula is QEQ is equal to your products over your reactants, right? All right, so let's work. Let's do our work now. So let's write it out here. So I know that my QEQ, right, would equal my H2, which is a product, and I2, which is iodine. So H2 I2 over H squared. Now, why did I put a squared here? The reason I put a squared here is if you look here, there's 2 in front of this one here. So this will go to the front over there, right? It'll become to the power of 2 in this case. That's how I like to think about it. Right, so now this becomes, now we just plug and chug our values. So my H2 in this case is what? 0.04, right? 0.04. Now I don't like to get messy with all units. I like to do my calculations first and then plug in any required units. So it'd be 0.04 times I2, which is 0.01 over this, which they give us 0.14. At the end, if we do our calculations here, it would be square, remember, and it would be 0.02. And if we look here, if we look up here, we'd see that the equilibrium constant they give us is 0.02. Therefore, my system, since my QEQ is equal to my KEQ, my system is in equilibrium. You guys should try part B on your own, right? So look at this information given to you, right? And plug it in and see what number you get. And according to the number you get, look at what is happening, right? Is my QEQ equal to KEQ? Is my QEQ greater than KEQ? Or is my QEQ less than KEQ? All right, so I hope you guys tried pausing the video and trying it on your own. Now let's work it together. So if our QEQ formula is H2 over, if it's this, right? If this is my formula for QEQ, then if we plug everything in, it would be all over, right? And our answer would be 0.34. So therefore my QEQ is equal to 0.34. Now 0.34 is greater than the amount that they gave me, right? Which was 0.02. 0.02, right? So therefore my QEQ is greater than my KEQ. So what would happen then if we look at a chart here? If my QEQ is greater than my KEQ, then system must shift to the left. So our answer is the system must shift to be left.